Okay, let's continue. Now, manganese, chromium, ruthenium are all transition elements. Explain what is meant by transition element. Now, transition element is going to be any element, okay, that can form, one or more, one or more stable ion, okay, that is the term that we need to use, stable ions, okay, with incomplete d orbitals. Okay, incomplete d orbitals. So please take note, there are two things that you need to take note over here: incomplete d orbitals and stable ions. Now, so if we continue further, okay, so okay, hold on. Okay, if you continue further, okay, they have mentioned that this SN 2 plus, okay, they can give you SN 4 plus. They can by using oxidizing agents. So these are the two common oxidizing agents. Okay, potassium manganate, potassium dichromate. They are very common, okay, in chemistry. So when you are using this oxidizing agent, you are going to have SN2 plus changing into SN4 plus, which are going to be colorless. So now we need to describe the changes that we see when SN2 plus is added separately. One, okay, with dilute acidified MnO4, okay, and then dilute acidified Cr2O7. So it's an oxidation reaction. So what generally happens is MnO4 minus, they will change into Mn2 plus, and Cr2O72 minus, okay, the dichromate, they will change into Cr3 plus. It is very important to know the color change. This is going to be purple, they will become colorless. Okay, please take note. And this is going to be orange, and they will change into green. Must remember. Okay, must remember. Now, write an equation for the reaction between SN2 plus and acidified potassium dichromate. So to help you to write, I have written in advance. SN2 plus is going to become SN4 plus 2 electron. So this one you should be able to write down. Okay, no need to refer anywhere. Okay, but if you really cannot, then I think you are given your data booklet. You can get it from your data booklet, but you shouldn't be looking at the data booklet. I think you should know. Okay, Cr2O7, they must give you Cr3 plus. So I put 2 there, and then they must have water. So here must have H plus. So must have 7. So 14. So the rest is going to be 2 minus. Okay, 2 minus and 14 is 12. Okay, so the charges here is plus 6. So you need total 6 electrons to make it 6 and 6. So you should know about how to balance this. Okay, what is important now is to join these two equations together, these two half equations. Do remember that they have 6 electrons here. They only have 2 electrons here. So I need to times this equation by 3. So when I times that equation by 3, I am going to get 3SN2 plus. Okay, then this one plus Cr2O72 minus, okay, plus 14H plus. The electron will cancel, so it's still 3SN4 plus 2Cr3 plus 7H2O. Okay, this will be the equation that we are going to look for. So you must make sure you write the correct equation. Okay, so in order to do that, you need to write the half equation and make sure you write the correct half equation. Now, ruthenium forms complex ions. In one such complex ion, X, okay, ruthenium ion has a coordination number of 6. Each of them, okay, has Ru2 plus and then Cl minus ion and one SO2 molecule. Now, they already give you, okay, a hint over there. This is a molecule, so it's a neutral molecule. And the remaining ligands are ammonia, so this is also neutral molecule. So the SO2 molecule acts as monodentate ligand, so only one coordinate bonding over there. And it is attached to Ru2 plus ion via sulfur atom. It means the sulfur is the one that is giving the lone pair of the electron to be bonded. So X exists in 2 isomeric forms. Okay, later we'll look into that. State what is meant by coordination number of 6. Okay, it means that they have 6 coordinate bonds. Okay, 6 coordinate bonds. Okay, coordinate bonds. Okay, but it's not enough to just simply say 6 coordinate bonds. You must say 6 coordinate bonds to where? To the central atom. Okay, in this case, this is not atom. This is going to be to the central metal ion. Okay, so please be write it completely. They are asking, if you check in your marking key, they want this, this, and this must exist together to get the 1 mark. All 3 must be there. So 6 coordinate bonds, is it going to result in 1 mark? The answer is no. Okay, 6 coordinate bonds to the central metal ion. Okay, this is very important. Okay, now state the formula of X, include its charge. Okay, so we need to state the formula of X and include the charge. So here I have Ru2 plus, okay, and then you have 1 molecule over here, another 1 molecule over here, and then 4 molecules of ammonia. So when I write down, it will be Ru, okay, then I have SO2, so I put SO2. And then I have Cl minus, so no need to put the Cl minus, okay, so it's still fine, just put 1 Cl, and then ammonia, NH3 is going to be 4, then you put a bracket. Now the bracket, when you put, okay, you see the charge is going to be +2, this is going to be 0, this is -1, this is 0, so +2 plus -1, the charge is going to be +1. So you need to write down the charge of the overall molecule, overall transition complex is going to be plus. So this is going to be very important. Okay, so state the formula. It's all written over there. If you are wondering whether is it matter if I put like this in the marking key Ru, then after that ammonium, they put 4, and then they put Cl, okay, then they put SO2, okay, bracket, they put like this. Now it depends, it's relative. Why? Okay, if I'm examining you, I will give you this correct, but the correct way to write this is going to be this one. Why I say this one is going to be correct? Because we follow alphabetical order. This is ammonia, this is going to be chlorine, and this is going to be sulfur dioxide. Okay, so sulfur, related to sulfur. So A comes first before C, then after that S. So they follow alphabetical order. Okay, so if you are wondering why it's slightly different, okay, this is based on alphabetical order. So if you want to, if you're rushing for your time, okay, it's fine to write it in this way. If let's say you have the time and you want to check it properly and you really need this 1 mark, okay, then I think everyone needs that 1 mark. Okay, please rearrange them according to alphabetical order. Okay, so don't follow N, yeah, don't follow N, it's ammonia. Okay, so it's not N, so it's ammonia, so follow that. Okay, that is done. Now draw 2 isomoric forms, okay, of X in the space boxes below. Okay, your diagram should show the 3-dimensional shape of 2 isomer and how each ligand is attached to the central ruthenium ion. So they want you to show, okay, and this is going to be a 3D diagram. Okay, please remember this one is still my working. Okay, this is still my working. I'm still wondering like how do I show? Okay, I have ammonia, 4 ammonia. How do I show using ammonia, 4 ammonia with SO2 and Cl? How do I show the isomer over here? The one that I can think of is going to be cis and trans. So how do I show cis and trans? So the only way that I can think of the 2 different groups that I have is SO2 and Cl. So I can put something SO2 here and put Cl, okay, make it a cross, okay. And then another one that I can think of, put SO2 here and Cl, put it side by side. And the rest of them is going to be ammonia. This is my working that I'm going to draw. So what I will do, okay, if I want to draw, okay, please remember it's 3-dimensional shape. So you draw accordingly like this, okay. So this one is going to be like this and like this. Okay, then you put Cl. This is ammonia. And then this one will be, you can draw like this. I'm sure you've seen many times already like this. Okay, and then this is SO2. And this is going to be ammonia. And draw, this is going to be ammonia as well. Ammonia. Okay, this is how you draw. And make sure, okay, they are connected properly. You can see here, the thing is, they want you to make sure that each ligand is attached, okay, properly. So if you want a very good mark, okay, I will also suggest to be very careful with the one that you attach. Like for example, okay, if you have SO2, I will strongly suggest, okay, you put, okay, S, okay, you show they are going to be bonded to S. So it's going to be S2, SO2. So maybe I'll just put O2 here, okay? So that it is showing that it is bonded to sulfur. And then this is ammonia. So ammonia like this. Nitrogen here, okay? So I think it's better if you write it in this way. And then nitrogen here. So maybe like this. Nitrogen here, maybe like this. So please write accordingly. So here, okay, if you do the same thing, I try to copy here and I put here, paste. Okay, so what I can change over here is going to be, I will change this, okay, this part, okay, because I want to show, this is going to be trans, okay. So I want to show them cis. So how do I, sorry, this is going to be, I am showing, okay, trans, correct. So this one I want to show cis. So I will show them, okay, maybe I put the SO2 there. Cl, I put it here. Okay, Cl, I put it here. And then here I will put NH3. Okay, so this is how I draw. Okay, please be very careful with this. Okay, the important thing is how you show this. Okay, some of you might ask, okay, sir, do we need to show this thing? Okay, in this case, I don't see it drawn in the marking key. So please follow the one that I have drawn over here. Okay, so different arrangement, as long, okay, they do accept, as long that your Cl and ammonia, they are, if they sorry, the Cl and SO2, they are across, then it's trans. As long your Cl and SO2, they are side by side, then it's going to be cis. Okay, so that is going to be how they are going to give you the mark. Suggest the type of isomerism that you are having over here. The type of isomerism that we have over here, this is going to be cis or cis trans. Okay, or if you want to write down, you can say geometrical isomer. Only one, select only one. Okay, cis trans or geometrical isomerism. Now explain the origin of color in transition element complex such as X. Okay, this one we have done many times already. Okay, so it is 3 marks. Okay, so please take note, there are 3 important points that you need to consider. So I've written down some important points over here. Okay, when you have this kind of situation, okay, the presence of ligands, okay, will split the d orbitals. Okay, you must mention it's d orbitals here. They will create 2 sets of non-degenerate d orbital. It means different energy level. Okay, non-degenerate orbitals. And then when there is a light, okay, the electron, okay, they absorb the light, okay, the light energy, and they jump from lower energy, or the electron will become excited, okay, from the d orbitals from the lower energy, and they will jump to the d orbital with the higher energy. So this one is related to that. And this energy that is going to be absorbed from the light, okay, once it actually goes away, after they pass through the sample, they will transmit light colored, okay, which is going to be complementary to the color that we observe, okay, because it's complementary to the color that is going to be absorbed. Okay, It's complementary to the color that is going to be absorbed. So how do I explain over here? Okay, so important, okay, you need to say that the complex or the ligands, okay, the ligands, okay, they will make or split, okay, the d orbitals, okay, into two sets of non-degenerate, okay, non-degenerate orbitals. Okay, but please memorize, okay, d orbitals here, because I think we have tendency to say just orbitals. Okay, it must be d orbitals. That is the marks that is given also. So the visible light, okay, the visible light will be absorbed. Okay, will be absorbed by what? Will be absorbed by the electron. Okay, by the electron, where the electron will become excited. Okay, the electron will become excited or promoted. Okay, will become excited, and they move from lower degenerate d orbital to higher degenerate d orbital. Okay, when this is happening, okay, when this is happening, because of the absorption of the light, okay, so complementary color is absorbed. Complementary color is observed, okay, based on the light, the frequency of light that is going to be absorbed. So 3 marks: d orbital, different energy, light will be absorbed, electron becoming excited. These are the 3 points that they are looking. Okay, if you are not sure, please refer to the marking kit. These are the points that they are looking. Yeah. If you notice also, they don't use these degenerate orbitals also. Okay, they just say different energies. The meaning is still the same. Okay, so they have d orbitals with different energy. Okay, but in your textbook they say degenerate orbitals. So it's fine. Okay, you can use both. Now, number 8, protein are natural polymers. When one particular protein is partially hydrolyzed, the product mixture includes the tripeptide E. So this is going to be tripeptide. So here describe the condition that can be used to hydrolyze E to produce a mixture of 3 amino acids. So if you want 3 amino acids, okay, so we need to break the peptide bond. Okay, the peptide bond is going to be between this NH and then carbon double bond O. Okay, so we want to break that. Okay, so I want to break here. I want to break over here. So if that happens, you are going to get molecule number 1, molecule number 2, molecule number 3. So 3, yeah, 3 mixture. So we want to describe the condition. In order to break the peptide bond, okay, this bond can be broken based on three conditions. Okay, but out of these 3 conditions, please remember we didn't focus on this condition. Okay, I'll make it bigger. So this one is called hydrolysis. Okay, hydrolysis. So this hydrolysis can happen in either, okay, acidic condition, or they can also happen in alkaline condition. Okay, let me check whether you can still hear me. Okay, I know I'm a bit laggy now. Okay, but I just check again whether you can hear me. Okay, I think should be okay now. So you see, I was talking about hydrolysis. Okay, so there are 2 types of hydrolysis. Okay, which is going to be acid hydrolysis, and we also have base hydrolysis. But we didn't really spend the time to go through this one. This one is by using enzyme. Okay, you can use protease, okay, at the temperature of 30 to 40, okay, around your body temperature. So this is going to be also possible, but we didn't learn so much about this. So I want you to either use this or this. Okay, dilute sodium hydroxide, okay, aqueous, okay, and then heat under reflux, or dilute hydrochloric acid or dilute sulfuric acid, you heat them under reflux. Okay, so you can use any of these. Okay, so you need to select one. Okay, so because the following question, okay, this question is related to A1. So let's say I'm going to select, I'm going to use dilute sodium hydroxide, okay, aqueous, and then heat under reflux. So let's say this one is what I decided to select. So when draw the structure of 3 amino acids produced in this hydrolysis reaction. Okay, so you need to draw the 3 structure of amino acid. The 3 amino acids should be shown in the correct form for the condition you have chosen in A1. So please remember, it doesn't follow 100% in what is given in the marking key, because in the marking key they just show you the general part only. So your marking key is just a guide. Okay, it's not the final answer. Okay, the final answer would be something like this, where when you are using dilute sodium hydroxide, when this one is broken, okay, so you see here, you are going to get this molecule, and then this part, okay, that I broke over here, you will get NH2. Okay, just put another H over there. So here, okay, once you have this amine and so on, when you react with sodium hydroxide, do remember sodium hydroxide, they do react with this carboxylic acid group. So this part, okay, so they will react, and the Na, okay, the Na will join in, okay, so the Na will join in. So you are going to get the Na plus, okay, will come over here. You are going to get this salt. Okay, so the salt will be there. Okay, if you don't write the salt and you just put O minus, I think that is also accepted. Okay, but here, since I'm using NaOH, yeah, the Na will come over here. So that is going to be my answer. And if you look over here, this one is carboxylic acid. So again, carboxylic acid, they do react. Okay, this part, yeah, they do react with NaOH to give you the O and A. Okay, so you have O and A over there. So here the same thing, this one, okay, alcohol, okay, the alcohol group, when I react with the sodium hydroxide, okay, alcohol, okay, this one, wait, let me check. Okay, so alcohol, this one is my mistake. Alcohol do not react with sodium hydroxide, so it will stay as OH. Okay, do remember, okay, alcohol can react with Na. Okay, alcohol can react with sodium, but alcohol do not react with NaOH. No reaction. Okay, no reaction. But phenol, on the other hand, they react with sodium. Okay, and phenol, they also react with sodium hydroxide. Okay, please be please take note of this. Okay, phenol, they do react with sodium hydroxide. So you are going to get, if I put like this is phenol. When they react with sodium hydroxide, you are going to get the phenoxide ion, O minus and A plus, and then H2O. This is going to happen. Okay, but alcohol itself do not react with NaOH. Okay, this one I already mentioned to you earlier. Okay, about this, please take note. So here it comes over here into practice. Yeah, the OH do not react with sodium hydroxide. OH will be there, and then this NH2. This one is NH2. No reaction with NaOH. So you have that. So here, okay, you have carboxylic acid group over there. Same carboxylic acid. They will join, okay, with NaOH to give you this compound. And then for this part, okay, NH3 plus. NH3 plus, when I react with NaOH, the H plus will go here. They will join with the OH to give you water. Okay, so it means that the NH3 plus will become NH2. Okay, so that's why I put NH2. And then here, similar, okay, when you have carboxylic acid, okay, carboxylic acid, they do react with sodium hydroxide. Okay, so when I react, okay, I'm going to get this. Okay, so please take note of all these products, okay, when you do the hydrolysis reaction. Now, if a pure sample of E okay, is obtained in aqueous solution. Several different types of intermolecular forces are possible between pairs of E. So you see, there are a few different types of intermolecular forces that can exist, okay, when you have this. So what are the intermolecular forces that can exist? Okay, because you need to think. Intermolecular forces, we have learned about permanent dipole-dipole. You have learned about van der Waals forces, okay? Um, with the others not showing the salt. Aneta, what do you mean? With the others, like, it means that if it is going to be, if you are using HCl, okay, then it's going to be different also, Aneta. Okay, if you're using HCl, then carboxylic acid group will still be there, okay? But you know the NH2 over here, the NH2, they will react with the HCl. You are going to have NH3Cl. So you will not get the NH2 there. So please check accordingly. They will have different product. Okay, they have different products. So for if you are using HCl, then this part will be OH. Okay, but this part, the anything that has NH2, then they will have NH3Cl. They follow accordingly. Okay, so that's why they give you some kind of a general equation over there, okay, so that you can follow. Okay, so if write NH3, do I still get a mark? If you simply write NH3, do you get mark? Do you get mark? I don't think so. Okay, but let me check the marking key, yeah, Aneta. 3 amino acid in any ionic or non-ionic states, 3 amino in the correct ionic state. Okay, you will get 1 mark, Aneta. Okay, but you will not get the full mark. Okay, so imagine you need to get, if you have anything wrong in one of this, then automatically 0. So it means everything is correct. Okay, you still use the NH3 plus, you will not get the 2 marks. You will get only 1 mark. Okay, please take note of that. Now, next, okay, so here they want to know the intermolecular forces. The intermolecular forces that are going to be there, okay, we have permanent dipole, permanent dipole, permanent dipole, dipole. We have hydrogen bonding, okay. We can have van der Waals forces, okay, but I think on top of the van der Waals forces, when I see this positive charge and negative charge over there, I think better to say that ionic bonding will be there. Okay, so they do accept van der Waals forces, okay, but I think here when you look at this diagram, automatically it's ionic bonding should be there. So I'm going to select this PDPD. Okay, what is PDPD? Is going to be permanent dipole. Okay, permanent dipole, permanent dipole dipole. Okay, permanent dipole dipole, and it is going to be between what and what. So basically PDPD is between anything that has delta positive and delta negative. So the one that has delta positive partial, yeah, not completely negative, completely plus. So partial negative, this is partially negative. Okay, partially positive will be example, maybe the hydrogen is partially positive. Okay, so that's going to be partially positive. So between NH and O, okay, then there will be a possible interaction. So do remember, it's not the same molecule. It must be different molecule. So we are talking about the pair between NH and CO. So if you want to give, okay, NH and CO, okay, so they might have permanent dipole-dipole. Hydrogen bonding, so you need to look for anything that has the H plus, okay, the partial positive of H. So partial positive of H can happen, I think here, partial positive of H, partial positive of H can. So then must be something with a partial negative, but it must involve O, N, and F. Okay, so I have oxygen there. Nitrogen is also there. Okay, so you can choose which one you want. Okay, so you can either write down NH and OH. Okay, NH and OH. So this is delta negative. This is going to be delta positive. Okay, so that is going to be hydrogen bonding. So the ionic bonding, so you need to tell, okay, this NH3 plus NH3 plus and COO minus. Okay, so that is going to be another one. So ionic bonding. So you see, when they give you the marks, okay, they are going to determine whether, okay, in order to get the full mark, okay, it means that in order for all this to be correct, you need to mention the correct pair. Okay, you need to mention about correct pair, and then you need to also mention about what like for example, if you just say ammonium NH3 plus alone, it's not enough. You need to mention the NH3 plus and COO minus. So you need to explain. Okay, if you have time, please explain. But I think the one that they want must have this together with this. Then only you can get 1 mark each. So you get 3 marks. Okay, if it is anything missing over there, you can see in the marking key they mention both. Okay, they mention both. So if you don't write, okay, I don't think so you will get the marks. Okay, so each, even this one also both. So you need to mention. Okay, now next, okay, polyester and polyamide are two important types of condensation polymer. Draw the structure of one compound, okay, a compound that can polymerize to form a polyamide. Okay, polyamide. How do I get polyamide? Okay, I get amide linkage. What is amide? C double bond O and then NH. Okay, so this one is going to be amide linkage. So I get it from this C double bond OOH with anything that has NH2. Okay, I get it from there. So I need to find out a compound that can polymerize without the need of second monomer. Whenever they say without the need of second monomer, it means the compound itself has these two groups. So quite simple. Just put C and then you put carbon double bond OH like this. Okay, this is going to be one part. If you want, you can put C. If you want another C, also doesn't matter. Doesn't matter how many C that you want to put. Okay, but make sure that the end of this you put NH2. So it doesn't matter how many carbon that you have. Okay, they just ask you to draw the structure. So doesn't matter how many carbon in middle you have. Okay, but okay, you must make sure that okay they have the carboxylic acid. You must make sure that they have NH2. Okay, that is going to result okay in a formation of this condensation polymer. Okay, can we write another type of answer? Yeah, possible. Okay, another type of answer that you can have is going to be you can also react. Okay, you can also react mm, if let's say you don't want to put NH2, I can also react with Cl. Okay, so it means if I have like for example C double bond O Cl and then I have NH2, okay, then it's possible also because there is going to be, you are going to get peptide linkage also. So here maybe another molecule that you can draw is maybe like this and then Cl, C double bond O, Cl, CH, maybe C NH2. Okay, that is also possible. Okay, please choose which one you want. Okay, so you can either use the one that involves the carboxylic acid and then NH2, or you can choose the one that has the acyl chloride and NH2. It's possible. Next, okay, draw the structures of two different compounds that can polymerize together to produce polyester, okay, with 4 carbons present per repeat unit. So draw the structure of two different compounds. Okay, so it means per unit must have two. It means 4 carbon atoms. So maybe what I do is I will take 2 carbon here, another 2 carbon here. So total when they join together, they are going to get 4 carbon atoms per repeat unit. So I can use a lot of combination. So maybe I can use, okay, something related to diol, okay, OH and OH. Then they react with something that involves the dioic acid. So they can also give you the polymer. Okay, this is going to be not in the same molecule. Now they are different monomers. Okay, you can also use, okay, the this one, okay, the carboxylic acid. Okay, sorry, because carboxylic acid, this one is quite vigorous. Okay, but here this is more reactive. So you can also use ethanol chloride. Okay, with the alcohol also, different combination. So if you want, okay, I will write down OH, and I will write down carboxylic acid here. You can write down different combination also. Okay, I will write down using different pen if I'm using different combination. So maybe I'll use OH, but here I'm going to use Cl, and then Cl. So also the same. So I'm using the 2 carbon and 2 carbon when you join, and then it's 4 carbon here. So please take note of that. Okay, so the rest you just put the hydrogen and everything, make sure everything's properly done. Okay, I'll take this as my answer. If let's say the one circle, okay, if I want to give the name of the compound, this is going to be a diol. Okay, so what kind of diol? So this is going to be ethane. Okay, ethane 1,2 diol. Carbon number 1, carbon number 2. So this one is going to be ethanoic acid. Okay, but now you have 2. Okay, so this is going to be named as ethane dioic acid. If let's say I choose this one, what is going to be this name? This one is going to be ethane dioyl chloride. Okay, that's why it's a bit difficult. Okay, I think better to use ethane dioic acid. It is inside your textbook also. Okay, next, number 9. Okay, the structure of butanben, okay, is shown. So butanben acts as a base. Okay, so if it is a base, okay, it's going to be a proton acceptor. So they can accept proton. So when they accept proton, H plus, so it means base itself, they must have lone pair of electron so that they can donate the lone pair of electron to the proton. Okay. So here, the only thing that I can see over here that might have the lone pair, maybe this one. Okay, maybe this one also, they have lone pair. Okay. Even this one, okay, they have lone pair also. Okay, so complete the equation, okay, for a reaction where butanben acts as a base. Okay, so if you have in this kind of situation you want to write down, I think most of the time I will select this one. It's much more easier, okay, to show it as a base. Okay, so let's say I'm going to react as a base, H plus, reacting with the proton. So what will happen, okay, is going to be, I'm just going to redraw this. Okay, so I just redraw this, and then NH2, okay, but now it will become NH3 plus, okay, because H plus came in. And then, okay, if I draw the same way, so I have like this, O, okay, like this. Okay, this is going to be the equation. Now predict whether butanben is stronger or weaker base. So this one maybe I'll ask someone. Jody, do you think butanben is a stronger or weaker base than ammonia?
Weaker.
Okay, if it is weaker, why?
The nitrogen overlap with the benzene ring, so less able to accept proton.
Okay, it's correct, but not the nitrogen is overlapping. Okay, please take note. Okay, so the one that is going to happen is going to be the electron, the lone pair of electron, okay, they will become delocalized into the ring. Okay, so the structure is going to be stabilized by the benzene ring over there. So it means that this lone pair, okay, since they are entering the ring, so it's not readily available. Okay, not readily available. If it is not readily available, so when H plus comes in, they cannot, okay, accept the proton. Okay, they cannot accept the proton easily compared to ammonia. So that's going to be the answer. So it's weaker. That's going to be 1 mark. Okay, weaker. Okay, but again, you need to explain. So if you don't explain, then it's going to be wrong. So you must say weaker because, okay, because the lone pair of electron at nitrogen, okay, is delocalized into benzene ring. When you want to mention about overlap, I think you need to say the p orbitals, okay, the p orbitals overlap with the p orbitals in the benzene ring. But I think it's not so clear over here if you want to look into that. So I think the best way is to say the lone pair of nitrogen, they become delocalized into the benzene ring, okay, making it less available, okay, making the lone pair less available for bonding with proton, okay, compared to ammonia. Okay, that's going to be 1 mark. Now complete the reaction scheme below to show the structural formula of the products when butanbane is treated separately with the stated region. Now if you look at Br2 over here, okay, the first thing I think you will be thinking is, where do the Br2 go? Okay, so because I don't have any double bond over here, so if it is Br2 just aqueous at room temperature, how come the reaction can continue? The reaction will continue, okay, because normally we think that if you have Br2, we need to have a halogen carrier, but okay, you do not need to have a halogen carrier because of the presence of NH2 over there. This NH2 will donate, again the same, the lone pair of electron of the nitrogen, they will enter the ring, okay, enter the delocalized ring, and they will become like make this ring to become more highly, the charge density will be more. So when the charge density is more, okay, the electrophile such as Br over here, they are going to be attracted directly over there, and they are quite reactive. It means they will be attached to the benzene ring without the need of halogen carriers. Okay, but you need to take note because they are electron donating group, okay, similar to CH3 and so on. So since because they are electron donating group, they will activate position 2, 4, 6. And you can see this position 2, okay, position 4 is taken, so 6. So it means when you draw this, okay, you are going to get something like, I will draw NH2. So here Br will come here, Br will come here. Okay, this is going to be the structure that we are going to look. Okay, so no need AlCl3 like what I written over there. Okay, now this is going to be the production of azodi. Okay, the production of azodi, it happens from temperature 0 to 10 degrees Celsius. Do not get this confused with nitration reaction. So this one is going to be, you need to form this, okay, from normally we form with NaNO2 plus HCl, then you get this and this one. Okay, they will react with this phenylamine. Okay, so when you have phenylamine, what is going to happen? Okay, you are going to get a molecule. Okay, I will draw the molecule. You are going to get the molecule that has the N2 plus. Okay, so I put like this. This one I just put N2 and plus. It's enough already. I think last time, I do not know whether Gabriela, Nicole, or Aneta was asking me about this question. Do we need to know how they really form N2 plus? No need to know. Okay, no need to know. Okay, the reaction is when this one comes here, okay, the nitrogen over there, okay, they are going to form this N2 already. So no need to know how it forms and so on. Okay, so this one you just need to memorize only. If you want to give the N2Cl, okay, it's fine. Okay, if you want to give N2Cl, it's fine also. Okay, so if N2 alone, then it must be positive. Okay, the next is going to be NaOH under reflux. Okay, so sodium hydroxide under reflux. Basically, we are trying to break the ester. Okay, so this one, this bond, okay, will be broken. Okay, so so here when you do that, okay, you are going to have two products. Okay, so one is going to be this one. Okay, you can draw properly. Okay, I'm just roughly drawing. Okay, so I have this, and then OH. Okay, and then here you have another one which is going to be OH, then something like this. Okay, so this is going to be the structure. Okay, so you are going to get two compounds here, and because of the reflux. Okay, so again, okay, please take note, since you are using NaOH, okay, you cannot leave the answer like this. Okay, you have to do, okay, the carboxylic acid will react with the NaOH, so you need to erase this part and say there is O minus and Na plus. Okay, very important. Okay, even here in the marking key they say O and A. Okay, if you write down also doesn't matter, it's still going to be accepted. Okay, so two things must be there. And then next, okay, the proton NMR spectrum, okay, of butanediene in CdCl3 contains one or more peaks that shows a triplet splitting pattern. Now, so for triplet splitting pattern, so you see here the triplet splitting pattern. This one, if you are using CdCl3, okay, we are going to use like there is more splitting, and it's also proton. Okay, so why there is a splitting? Because the carbon that is next to the proton environment, the next carbon that's next to the proton environment, they if they have the number of hydrogen, you need to use the n+1 formula for the splitting. Okay, so you need to consider about that. So for now, when I want to see like state the number of peaks in the spectrum that shows a triplet splitting pattern, okay, it means that I need to see where which of them, okay, which hydrogen environment is bonded to carbon that has two hydrogen, okay, because triplet. So 2 plus 1. Okay, so I'm looking for anything that has the two hydrogen. So here, if I look at this carbon environment, hydrogen environment, this carbon is only 1H. Okay, so if it is only 1H, then when I put n+1, that's going to be 2 only. Okay, so that will not be the answer. So if I do further, like for example, for other hydrogens, okay, like for example, this hydrogen, for example, if I'm looking at the carbon next to it, okay, I'll share the screen again. Hold on. Okay, you can see the screen now. Okay, if I have this environment over here, I can see there is no carbon beside here. Okay, there's no carbon here, but I do have one carbon here, and then they have another two hydrogen. So for this environment, okay, for this environment, I have the one that I circle. Okay, let's wait. for it to appear. Okay, it appeared. So if you look over there, okay, this environment, okay, they are going to have um, opposite to this carbon is going to be 2 hydrogen. Okay, because of 2 hydrogen, so 2 plus 1 then is going to be 3. So for this environment, I am going to get triplet. Okay, I'm going to get triplet. So let's look at this environment. For this environment, will I get triplet or not? Okay, carbon, hydrogen, hydrogen. Now you see, for this environment, I have 1, 2, 3, 4. Okay, let me use different pen. 1, 2, this is carbon next to it. Another carbon next to it, 3, 4. You are not going to get, okay, triplet. You are going to get 4 plus 1, 5. Okay, for this, you are going to get 5. For this, you are going to get 3. I hope you can understand this. Okay, and then for this one, this carbon H, H, H. For this environment, each of these hydrogen, they have the same environment. For this environment, the carbon next to it, okay, you have 2 hydrogen. So possible. This is also going to be 3. So how many of them, okay, they are going to have, okay, how many of them they are going to have 3 triplet? Okay, the answer is going to be 2. Okay. Now, Aneta was asking, sir, is it acceptable if we just use R as the R group, like NH2, R, CO, Cl? It's possible, Aneta. Okay, I think the one you're asking is the one that we simply put. Okay, but again, do remember, don't use the R in the middle. Anita, so I advise you not to do that. Okay, why? Because NH2, if you put NH2, then RCO Cl, okay, because R is NH3, CH3 or C2H5. If you are referring to this one is CH2 only. So it's not suitable. Okay, it's not suitable. But you can use like this, CH2 bracket N. It's possible. Okay, CH2 bracket N. Then you put NH2 here. And then you put COCl. Yeah, definitely going to be accepted. Okay, next. Okay, next. Here, okay, I was mentioning about just now. Okay, number of peaks, okay, that shows triplet. So you are going to get 2. Okay, I hope you understand from this explanation. Yeah, this one and this one. Okay, I think here they will ask on the diagram of Butanban, show circle the proton responsible for the peak. So circle this one. Okay, these two, they because of this and this plus 1, so get 3, and then this 3. Okay, because of that. Okay, if you are still wondering about why this one and this one not there, okay, please remember this hydrogen 1, 2. Okay, 1, if let's say I use a different pen, yeah, for this environment you have 1, 2, 3, 4, 5. So instead of 5, only 5 plus 1. So you have 6. Okay, so please remember, okay, they will combine. Okay, they will combine. So anyway, okay, describe and explain how the proton NMR spectrum in Butanban in D2O. So now you are using heavy water. Now, if you are using heavy water, okay, the difference is anything that has the NH or OH, they will disappear. Okay, the peak will disappear. So here I do have this peak over here, which is going to be responsible to the environment attached to nitrogen. Okay, so that peak will definitely disappear. Okay, so how do I explain that peak is disappearing? So you just say one less peak. Okay, which peak is that? So NH2 peak. Okay, NH2 peak. Why is that? Okay, because there is a proton exchange. Okay, there's a proton exchange or rapid exchange with the deuterium atom. Okay, so rapid proton exchange with D. So here, do remember 2 marks. Okay, if you don't say rapid proton exchange, also doesn't matter. You say one less peak, and that belongs to NH2 peak is good enough already to give you the 2 marks. Okay. Now the next is going to be the mass spectrum, the last one. Yeah, the mass spectrum of butanban includes the 92 and 57. So if it is 92 and 57, please find out which one do you separate, because you can separate into like break here, then you get CH3 plus. You break here, then you have CH2, CH3, then this is going to be plus. So please find out which one will give you 92 and 57. So normally, okay, what I do, okay, because 92 is a big number, so what I do, I try to count this one, okay. So this is going to be C6, okay, C6, and then there is NH2, so I put NH2 there. So one of the hydrogen will be gone, yeah, because C6H6, if it is substituted here, so H4, okay, so C6H4 and H2, then I break over here, so it's supposed to be plus, okay. So see whether what you get over here, C6H4 and H2. So 6 times 12, you can use your calculator, plus 4, plus 14, plus 2. Okay, see what you get. Okay, you get 72 plus 4, okay, plus 16. So 20, 20, 72, 92. So yeah, you can have C6, H4, and H2 plus. This is going to be the answer for that. Then 57. Okay, of course, nothing to do with this. Okay, because 57 is supposed to be smaller. So must be something related to either here, 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 or here. Okay, so you need to count. Okay, CH3 is 12 plus 3, 15. 15 plus 12. Okay, so you keep on doing that. Okay, so I will get something like this. I think it ended 1, 2, 3, 4. Okay, so 1, 2, 3, 4. I think it ended from here to here. Okay, you can calculate yourself. Okay, when you do that, okay, you will get 57. So this is going to be CH3, CH2, CH2, CH2 plus. Okay, so do remember you need to put the plus over there. Okay, so that is going to be the M over E, 92 and 57. Now, on top of this, okay, let me teach you one more. Yeah, okay, one more. Okay, if they say is suggest M over E is not 92, 92 divided by 2. Okay, so it's 46, for example. If it is 46, you can also give your answer as C6H4NH2 2 plus. This is accepted. Okay, please remember this. Okay, why? Because you take this one, 92 divided by 2. You get 46. This is also accepted. Okay, I want you to take note of this. Okay, so you can have anything. Okay, if you have 92 divided by 2 divided by 3, then you have 3 plus 10. Okay, so this one is going to be, they can also ask you on this. Okay, anyway, it's already 2:32. Okay, this one is done. Okay, so I will share this link, this video also. Okay, I will